Okay, this is the key for Chapter 9 test. I've already got the vocabulary filled in here. Just go ahead and pause um, and check those and go over those. Um, Number 21 says identify how the following two circles are tangent to one another. Don't tell me what tangent means. I know tangent means that they intersect at one point. But since one circle is inside the other, these two are referred to as internally tangent. Okay, that should be in your notes somewhere. Construct a picture so that there can only be one common internal tangent. That means that the two circles, it doesn't matter the size of them, but the two circles have to be externally tangent so that only one line, one tangent line can be drawn to both of them. Okay, a lot of people did this and just drew in one tangent line, kind of like that, being tangent there and tangent there. But you can also draw in that one. Okay, so that is not, those are two internal tangents. This is only one. Okay. Um, Going on to the next question, when a tangent is drawn from external point to a circle, uh, explain what is true about the tangent and the radius if the radius is drawn to the point of tangency. Well, those two lines have to be perpendicular. Okay. Down here, angle 1 is the same as angle K, so that's going to be D. Angle 1 is half. It's an inscribed angle, so it's half of K, so it's got to be A. This picture here is the same picture. Okay, it's still an inscribed angle, so that's A as well. Here, two lines, or an angle formed by two secants. That's when you got to subtract K and J, and then angle 1 is going to be half of their difference, so that's going to be E. And now here, angle 1 is that angle, so now it's adding K and J and taking half of that sum, so that's C. So those are your formulas for those pictures, and hopefully you got those right. Then you can use those later on in the test to get some of the exam or the questions down here correct. Here with these two, we learned that if we have two chords intersecting, the product of their parts, that part and that part, should equal the product of the 5 and the 4. Okay, so when I multiply x and x plus 8, I get x squared plus 8x, and 5 times 4 is 20. So we get 8x plus, or sorry, x squared plus 8x minus 20 is equal to 0. Two numbers that multiply together to give me negative 20 and out to give me positive 8 are x plus 10 and x minus 2. Well, that's going to say that x is equal to negative 10 and x is equal to positive 2. If x was negative 10, that would be a negative distance, so that can't work. So the only option is x to be 2. Looking at this one over here, we said that a secant and a tangent, the segments are proportional in the fact that the entire secant, which would be this entire distance right here, which is 2x plus 16, is multiplied by the external portion, which is just x. Okay, so the entire secant times the external portion should equal the tangent line squared. So the tangent line squared, 16 squared is 256. So now I get 2x squared plus 16x equals 256. It gives me 2x squared plus 16x minus 256 equals 0. Everything's divisible by that coefficient of 2 out there, so I'll take it out. And it'll leave me with x squared plus 8x minus 128 is equal to 0. And that'll give me x minus 8, x plus 16 is equal to 0. So that'll be x is equal to 8 and x equal negative 16. Well, if x was negative 16, that'd be negative. Can't have a negative distance, so that answer does not work. My only option is 8. Looking at this picture down here, The key thing for you to remember is that, and I tell you that this is DF is tangent to circle O at, um, DF is tangent to circle O, so you know that that's the point of tangency. This is a radius. That segment right there is a radius. That's your tangent line. From the first page, you told me that you knew tangent lines and radii, when they meet at the point of tangency, are perpendicular. So now, if I look at this triangle here, right now you have two angles of that triangle. You've got this 33 degrees down there, and you got this 90 up here. So this is 90, that's 33. To add up to 180, this angle has to be 57. Now what I know is I know all of these angles. I know those four angles. Okay, this one should be 83 if I want all five of those angles to add up to 360. Okay, so that's 83 degrees. Now it asks me find the measure of arc DE. Well, arc DE is going to be that arc right there. Well, it's going to be equal to the central angle. Well, that central angle was 57. So it's 57 degrees. And then arc BC will be that angle, or that arc right there, which should be equal to its central angle, which was 83 degrees. 27. Find HG. Find the diameter of this thing. Seen this question in homework. If I know that this arc out here is 150, then I should know that G to F, that arc, is 30 degrees. And that's essential for this problem, because what you want to do is create that radius, which when I create that radius, I now have that angle right there, and that angle is a central angle. It should be the same as the intercepted arc. So if the intercepted arc is 30, if this arc G to F is 30, then this angle here is 30, making this 60, and you know O to E is 8 radical 3. Okay, and the side that's always across from 60 in a special right triangle is n radical 3. So when I compare these, n is my 8. N goes here, and then this side, my hypotenuse of this right triangle ends up being 2n, so that's 16. So I've got a radius that's 16. When I look at HG being the diameter, and you know it's a diameter because it goes through center O here, if that's 16, the radius is 16, the diameter has to be twice that, so it's 32. This question here, it says RS is tangent to circle Q, find X, so we know that that's a right angle. Hopefully you recognize you got the Pythagorean theorem here. That's 12, so that has to be 12 as well. So now I want to say x squared plus 12 squared, which is 144, should equal 20 squared, which is 400. So now I get x squared equal to 256, so x has to be 16. This question here, we've got that arc and that arc. What we're trying to find is this angle over here, or use that relationship between the red arc, the blue arc, and the green angle to help solve for x. Okay, we know that the green angle 40, because it's an angle formed by a secant and a tangent, is equal to the arc that's furthest away minus the arc that's closest, and then we take half of their difference. Okay, so if we were to look back up to this picture here, number 24, we're looking at that picture there. Okay, so we're going to use formula. If you look back at your answers, that was formula E. Okay, so that's the one we're going to use down here for this question. Okay, so we're going to take our angle 40 and say that is equal to the difference between x squared plus 12x and x squared plus 2x. Now the key thing to remember here is that, when I subtract these things, I want to make sure that this is in its own set of parentheses. because I want to subtract the entire quantity. Okay, if that wasn't if those blue parentheses weren't there, all I'd be doing is subtracting that amount, and that's not what I want to do. Okay, I want to subtract the whole thing. So what I get, multiply both sides by 2, I'll get 80 is equal to x squared plus 12x. Distribute my negative, so it becomes minus x squared minus 2x. That's the key part of having those parentheses. That negative goes there and there. If I didn't have the parentheses, it would only go to the x squared, and that would be a problem. Now I recognize that that and that are opposites. They cancel out. 12x minus 2x is 10x, which should equal 80 divided by 10. X is 8. You can go ahead, if you wanted to, go ahead and plug 8 back in to these two expressions, and once you find their values, you could subtract them, take a half of them, and you should get 40. What is the measure of an angle that is inscribed in a semicircle? That's a theorem we had, and that's always a 90-degree angle. 31 says find x and y if if measure of AB is 76 degrees. So AB, that arc there, is 76 degrees. If I look at x, it's that angle there. Okay, it's an inscribed angle. And we know that inscribed angles are half the arcs that they intercept, so half of 76 is 38. Now angle y intercepts the exact same arc. So it's the exact same 36. That angle there is going to be the same angle of 76. So that angle y is going to be half of 76, which is, again, 38 degrees. We had a theorem that said if two inscribed angles intercept the same arc, then those two inscribed angles are congruent, which is what we're proving here with our picture. Angle y and angle x intercept the same arc of 76 degrees, so x and y have to be congruent. Down here, a lot of us did not pay attention to the fact that we've got some information here with AB's tangent to circle OA and AF as a diameter. If AB's tangent to circle O, then we've got right angles here. So angle 7 right away, probably the easiest one to find, 90 degrees. Okay. They also tell us that arc AG is 100 degrees. I put that in for us. So, if that arc there is 100 degrees, angle 2 is a central angle, so angle 2 also has to be 100 degrees. Okay. So there's a 100. Now these two angles here have to be supplementary because AF is a diameter. Okay, so if that's 100, angle 1 has to be 80. Okay, so just filling things in as we go. If I know that that's 80, I don't need arc GF, but I do know now that that's 80 degrees out there. Might be beneficial here in a little bit. I also know that arc CE is 30. It's told in the directions right here. And arc EF is 25. Okay. Let's try to find 6 here. Just looking at DA and DG, they intercept this arc over here of 100. So I take 100, subtract 30 from it, which gives me 70, and then angle 6 should be half of that 70. So angle 6 is 35 degrees. Okay. This is 100. This ends up being 35. This was 30. If that's 30, that's 25. That's 55 total. So this arc here, all 3 of these arcs, that red one, this one 30, this one 25, they should all add up to 180. So if that's 55, what's this going to be, 125? Okay, now angle 8 is an inscribed angle, so it's going to be half that red arc that it intercepts. So half of 125 is 62.5. So angle 8, 62.5. Okay. Angle 3 now, a couple ways of finding angle 3. You know that this is the intercepted arc out here. Okay, and angle 3 is an inscribed angle, so half of 55 is 27.5. Or you could say, well, we knew that this angle 8 was 62.5. That angle there has got to be a 90-degree angle. So 90 minus 62.5 should still give me a 27.5. So there's two ways to find that angle. Angle 4 down here, kind of work with 4 and 5 together. We know from the directions that EF is 25, and we know that this arc out here is 100. Okay, those two arcs are formed by that chord and that chord. Okay, so what we know is that these angles, that angle right there, which is angle 5, is going to be half the sum of these two angles, or sorry, these two arcs. So I take 25 plus 100 is 125. Half of that is 62.5. So angle 4, I'm sorry, angle 5 is 62.5 degrees, because 100 plus 25 times a half. Okay. Now, angle 4 has to be supplementary to angle 5. If I look at these two things, I know what angle 5 is. 5 and 4 make this straight line, so 4 has to be supplementary to 5. So angle 4 is going to be 117.5 degrees. Each one of those was worth 8 points. Or sorry, each one was worth 1 point. Total is 8 points. Going through, kind of show you the point totals here. 31 was worth 2 points. 30 was worth 2 points. 29 was worth 2 points. This question here in the bottom. 28, 27, 26, all worth 2 points. 1 point each for D, E, and B, C there. And 25A and 25B were worth 2 points as well, piece. On the front, each one of these was worth a point. So 5 total for that question. That's 1 point, 1 point. 21 was 1 point. And then obviously all of these were worth 1 point. So it came out to be a total of 52. If you have any questions about any of these, please don't hesitate to come see me. The retake will be similar to this, different questions, same format.